Hello everyone, I welcome you all to another video. Today we are going to discuss some supervised and unsupervised learning algorithms. Majorly we are going to understand the difference between a supervised and unsupervised learning algorithm, and then we are going to see some important supervised and unsupervised learning algorithm and where are the areas where these algorithms can be applied. We are going to understand these topics by solving certain assignment questions. My name is Manas Pathak. I'm a student of IIPS DAVV. So let's start. The question 1 says, explain the difference between supervised and unsupervised learning. Provide examples of algorithms for each type of learning and discuss scenarios where each would be appropriately used. So let's first understand what is the difference between supervised and unsupervised learning. For supervised learning, input data is a labeled data where input features are mapped with their corresponding outputs. While in unsupervised learning, it uses only unlabeled data. That is the data only in which there are only input features and it doesn't require any outputs. The goal of supervised learning is to predict outcomes or classify data based on known labels, whereas the goal for unsupervised learning is to discover the hidden patterns, structures, or groupings in the data. The computational complexity for supervised learning is less complex because we already have a labeled data, so it provides a clear guidance to the algorithm. Whereas in unsupervised learning, since there is no labeled data, there is not enough guidance, hence there is more computational complexity. There are two types of supervised learning problems. One where we have to classify certain discrete tuples into an output. We have to basically classify input tuples into outputs into certain classes, which is called classification. And the other type of problems in supervised learning is to predict certain numerical values, which is regression. Uh, Whereas in unsupervised learning, there are two types of problems. One where we have to form clusters, and other where we have to find association between elements. For testing the model in supervised learning, we can easily test our models because we already have a labeled data. So we have the input and we have the correct output. So we can match the correct output with the predicted output of the model to test the our model. Whereas in unsupervised learning, since there is no labeled output with us, so there aren't much testing methods. Hence, we cannot test the model in the traditional sense, as there are no labels. Evaluation. Model performance is typically evaluated using metrics such as accuracy, precision, recall, and mean squared error, comparing predicted outputs to the known true label. So, as I have already told you in supervised learning, since we know what the correct values are, what the correct output is, it is easy to employ such evaluation measures to evaluate the performance of the model. Whereas in unsupervised learning, it is more challenging as there are no ground truth labels to compare against. Internal metrics such as sellout score or qualitative analysis are often used. Accuracy. Supervised machine learning methods are highly accurate, whereas unsupervised machine learning algorithms are comparatively less accurate. Application. Image classification, sentimental analysis, male classification are some application areas for supervised learning, whereas for unsupervised learning, these areas are customer segmentation, anomaly detection, recommendation engines. We are going to understand some of these application areas in detail further in this video. Feedback. In supervised learning algorithm, there is a proper feedback system as we already have the known outputs with us. So if there is something wrong prediction done by the model, then we can provide it with the feedback of correct output, which can enhance the learning of the model and can generate more accurate results in future. Whereas in unsupervised learning, since there are no outputs, there is no known output, unsupervised learning lacks a proper feedback system. Algorithms, for example, algorithms of supervised learning are linear regression, k nearest neighbors, decision tree, naive Bayes, and SVM. Whereas unsupervised learning algorithms include k means clustering, db scan, autoencoders, hierarchical clustering, and many more. Now we are going to look at some important supervised learning algorithms and unsupervised learning algorithm, and we are going to see how they can be used in real life applications. So first, supervised learning algorithm we are seeing here is linear regression. It tries to find relationship between independent and dependent variables by assuming a linear relationship between them, uses curve fitting method to find this relationship. So basically linear regression tries to find the relationship between independent and dependent variables, and it uses the curve fitting method for that. So what is the curve fitting method? Curve fitting method tries to find the best possible curve to depict the given data. In case of linear regression, we assume that the relationship between the variables is linear, but there are also different types of regression such as multiple linear or a polynomial regression, especially where the relationship between the independent and dependent variables is not assumed to be linear, and we can include other curves as well. Linear regression is used in prediction of house prices. So given the certain data, previous data about houses, we can use the model, linear regression model, to predict for future house prices based on the number of rooms in a house or the square area or the location. We can use the model to predict the house prices of some unknown houses which are not known to the model earlier. Decision trees. A decision tree is used to make decision by mapping out different choices and their possible outcomes. It has tree-like structure that starts with one main question called the root node, which represents the entire data set. From there, tree branches out into into different possibilities based on features in data. So basically, a decision tree has four main parts. The first is the root node, which represents the whole data set and starting point of a decision tree. From that point, for each possible decision, a decision tree branches into different branch. A branch is the line connecting nodes showing the flow from one decision to another. Then we have certain internal nodes which denote further decisions which are need to be made based on the data feature. And then at the nodes which are at the last are called leaf nodes, which are the endpoints which particularly denote a decision or prediction which is finally made by the using the decision tree. Decision tree is used in mail classification system, where we can use to classify mail as spam, non-spam, or a bill or a particular mail if it is a bill, or if it is some important information. So we can use decision tree in that system. So now let's look at some unsupervised learning algorithms. I am considering two algorithms here, which are k-means clustering and hierarchical clustering. In k-means clustering, the goal is to partition the dataset into k clusters such that the data point within each cluster are more similar to each other than to those in other clusters. So in k-means clustering, we are given several data points, which is our data, and then we form certain clusters and we classify those data points into the clusters. So every data point in our data would belong to certain cluster. Now the data points within a one cluster are more similar to each other. That is why they belong to a particular cluster, and these data points would not be much similar to some another data point which belongs to some other cluster. So data points basically which belong to one cluster are more similar to each other. Now let's see how k-means clustering works. So in k-means clustering, the number of clusters are already pre-decided by the data scientist. That means I can before the learning algorithms, I start the learning algorithm, I'll decide that there will be k number of clusters in my algorithm. Now after I've decided the number of clusters, I'll randomly allocate a cluster to each of the data point in my data. After that, I'll get into an iterative loop. In this loop, I'll find centroid for each and every cluster. So suppose if there are 10, I've decided that there will be 10 clusters in my data. Then for each cluster, I have to find its centroid. Now what is the centroid for a cluster? It is the vector which is calculated as average of features of the observations that belong to a particular cluster. Now once I have found the cluster, the centroid for all the clusters, now for each data point, I'll find the closest cluster to that data data point. So now if I have a data point, then for that data point I'll find the closest cluster to closest centroid to that data point, and the cluster of that centroid would be the a cluster which is allocated to that data point. So I hope you understand that, and we'll get into this iterative loop. With this iterative loop ends basically when there are no changes in the allocate assignment of clusters to the data points. This is that is when where our k-means clustering algorithm ends. It is used for anomaly detection. So we use it in detecting the outliers or anomaly data, which is data which does not belong to any particular cluster. So after k-means clustering algorithm ends, I found that certain amount of data, there is some small amount of data which does not belong to any major cluster and does not fit in any other cluster basically. So that data would be an outlier for me, which I can remove from my consideration. Hierarchical clustering, alternative clustering algorithm that does not require us to commit to a particular k. Another advantage is that it results in a nice visualization called dendrogram. Observations that fuse at bottom are similar, whereas those at the top are quite different. We draw conclusions based on the location of the vertical rather than horizontal axis, used in customer segmentation based on purchase behavior. So in hierarchical clustering, it differs from k-means clustering in the way that the number of clusters are not pre-decided. In k-means clustering, I have already decided there will be k number of clusters for my data. In hierarchical clustering, the number of clusters are made on the basis of the fusion or the similarities between the data points, and it uses dendrogram. So basically in a dendrogram, as we move up, the dissimilarities between the data points would increase. So for the most similar data points, the vertical distance would denoted them between would be less. It is used in customer segmentation basically to identify the purchase behavior. So if I'm launching certain product and I want to know from that which price point would be nice to set for that product, then I'll look at the customer segmentation and I'll find where the majority of my customer section lies, and that would help basically to know decide the price of the product. And it can also be used in the sense that if I have already decided the price point that I'm going to sell a product at particular price, and then I have to find out which customer section would be my target audience for this product, then also I can use the customer segmentation done using hierarchical clustering. So this was all about today's video. I hope you learned something. If you have certain doubts, you can drop them in the comment section. I would like to express my heartfelt gratitude to Dr. Shaligram Prajapat for guiding me throughout the semester. Consider liking this video and subscribing to my channel. I'll see you in the next video. Thank you.